Hi, welcome to this video on rationalising the denominators and simplifying of surds. Alright, if you want to pause this video and take notes here, that way we can actually concentrate a little bit more on the maths. Alright, so assuming you've done that, if you are unsure about any of these notes that you see up here, please have a look at my previous videos on multiplying surds and another video on dividing of surds. Okay, so assuming you're okay with these and you've taken the notes down, let's continue. Right, so we're given this, simplify that root 12 times root 27, okay? Now, straight away, I could jump straight in and do root a times root b is the root of a times b. But if I did 12 times 27, I'm going to end up with root of 324, which is, you know, to kind of sit there and go, all right, I've got root 324. Wow, it's a square number that goes into the root. You're going to sit there for a while, okay? Now, what I would do, instead of jumping in there, I would use the same rule but backwards first. So I'm thinking square numbers, right? So I can say that root 12 is the same as root 4 times root 3. And I can see that 27, again, I've got another square number, I've got root 9 times root 3. Well, that's pretty cool, because now I've got 2 root 3 times 3 root 3. Well, 2 times 3, that's going to give me 6. By the way, all these are equal to each other. And now I've got root 3 times root 3. And root 3 times root 3 is just going to give me 3. So my answer here is going to be 18. Okay, now you'll see these ones quite a lot. You'll get one of these, and then straight afterwards you're going to get given something similar, but you're going to be asked to add. Okay, so let's have a look at one of the ones involving adding. It's a root 12 plus root 108. Okay, root 12 plus root 108. We've already seen that root 12, I can turn that into 4. Root of 4 times root of 3, which is going to give me root of 2. Sorry, not root 2, it's just going to be 2 root 3. Now 108, I look at 108, I'm thinking, what square number goes into 108? Well, I know that 9 times 12 is going to give me 108. So I'm going to keep this plus sign here. Now, the main problem here is that people forget that that's plus, and they just kind of go 108 times 12, 108 plus 12, and they end up with root 120. This only applies to multiplication. Do not tell me that that is equal to root 120, because it is not at all equal to it. Please be careful of that. They will do, first question will be the one like one of the ones previously, you just have to times it, and this one will be adding. You cannot add surds unless we have the same basic surd. And you're going to see that this is going to turn out very nice and neatly like that. Alright, so I've got, that is going to be 9 root 12. So root 9 and root 12. It's going to be root 9 times root 12. Okay? But I know that root 12 is actually root of 4 times 3. So let's just do this, plus root 9 times root 4 times root 3. If you don't know where I got that, I got these from root 12. I just split that out. And I've got both of these, let's underline this, I've got root 9 times root 12 from root 108, using this method going backwards. Alright, so let's continue this. I've still got 2 root 3 over here, plus this is going to be 3 times 2 times root 3. So I've got 2 root 3's plus 6 root 3's. So I've got 2 peaches plus 6 peaches. Right? Got to realize that this is very similar to, if you want to think of it, this is 2a plus 6a. And it's going to give me 8a. So 2 root 3's and 6 root 3's is going to give me 8 root 3's. If you think of it like this, it does make a lot more sense why you can't simply add these together. Right? That's, you know, that's akin to saying 2a plus 3b is going to give me 5ab. Okay? It's most definitely not. So be very careful of that. Alright, so that's simplifying surds. And remember, when we add surds, you cannot use our multiplication rule. There is no adding rule for surds. Alright, so the next bit I'm going to have a look at is rationalising the denominator. Okay, now, when we talk about this, the reason we actually have to rationalise the denominator is because root 2 is actually equal to 1.41421, and it carries on going for a while. So if I had a fraction 1 over root 2, I mean, that's 1 over 1.414. It's not a nice fraction. So mathematics and the convention in mathematics is to not have surds in our denominator. Because surd is an irrational number. We don't want rational numbers in our denominator. We don't want to have to be 1 divided by a really long decimal number. It doesn't work nicely. So what we're going to do is we're going to rationalise. We're going to turn this denominator into a rational number. Okay? And the way we do that is actually very, very simple. If I keep up that example, 1 over root 2, if I wanted to rationalise this, I'm simply going to multiply it by 1. It doesn't seem like it's going to be any, make any change, because if say I had 6 times 1, it's just going to give me 6. I'm not going to actually change the value by multiplying it by 1. If you're okay with the idea that I can multiply by 1, then you must be okay with the idea that I can multiply it by, I don't know, let's say 6 over 6. Okay, so let's say I had 8 times 6 over 6, well 6 over 6 is 1, so that must still stay at 8. Right? I could then also, very similarly, I can multiply it by actually any number. Let's say the number b, let b represent any number, so the letter b, b over b, that should be 1. So 8 times 1 is still going to give me 8. Right? So instead of 1, I can have any number over any number. So I'm going to choose root 2 over root 2. Okay? Now I can use my multiplication of fractions rule. Numerator times numerator, that's going to give me root 2. 1 root 2, I'm not going to write the 1. Root 2 times root 2, I know that any square root times itself is going to give me a. So, I'm sorry, root a times root a is going to give me a. So root 2 times root 2 is going to give me 2. And there's my answer. Okay, let's do one that might be slightly more difficult. Let's do root 5 over root 2. Right, so let's do root 5 over root 2. Okay, if I want to rationalise the denominator here, I'm going to multiply it by 1, but in the format of root 2 over root 2. Okay, remember, it's always my denominator present in both the numerator and the denominator here. Okay, because that means that it's going to be 1. And again, I'm going to multiply across root 2 times root 2, that's going to give me just 2. And root 5 times root 2, that's going to give me root 5 times root 2. Root 5 times root 2, well, that's the same as root 5 times 2, which is going to give me the same as square root of 10 all over 2. Right, denominator, rationalise. And lastly, let's have a look at one more slightly difficult one. Let's have a look at 8 root 6 over 2 root 2. Okay? Now in this case, I've actually got 2 parts to this question. Right? I've got 2 parts. I've got my 8 over 2, and I've got my square root over my square root. I have to solve this first before I can rationalise the denominator, because I need to just have my square root down here. I mean, technically I could multiply it by 2 over root 2. 2 root 2 over 2 root 2. But it's going to make things a little bit difficult. I'm going to have to then simplify at the end. It's much easier for me if I actually resolve this section first. Okay, so this section here, I resolve that first. So 8 divided by 2, that's going to give me 4 root 6 over now just root 2. And now I can happily multiply them out. So let me move this up here so I'll have enough space. Alright, so we've got 4 root 6 over root 2, and we're going to rationalise now. So we're going to multiply it by root 2 over root 2. Again, I'm going to end up with my denominator being 2, and I'm going to have 4 root 6 times root 2. Okay, 6 times 2, that's going to give me root 12, 4 root 12, all over 2. Okay, and now at this point, if you're wondering how I got to root 12, it's just 6 times 2. I'm using this rule here, going to get root of a times b. Now at this point here, I can resolve this section here. This is 4 divided by 2. I can resolve that, which is just going to give me 2. And now I can think of my root 12, and I'm going to go backwards like that. Again, I'm thinking square numbers. I know that root 12 is the square root of 4 times the square root of 3. Square root of 4 is 2, and 2 times 2 is going to give me 4. So we end up with 4 root 3. If you're wondering where I got that, square root of 4, that's actually 2, so it's going to be 2 times 2. 2 times 2 is 4, and the root 3 stays the same. Okay, got a quick question for you coming up now. Okay, first question, or sorry, first with 2 questions there. In the first and second, I want you to rationalise the denominator, so solve by rationalising the denominator. Okay, pause the video, have a go, see how far you get. Okay, so for your first answer, relatively simple. You just got to make sure that instead of leaving it as 15 root 3 over 3, you simplify down to 5 root 3. You want to pause that and have a look if need be. For question B, a little bit lengthy, but to be honest, I've done it a very long way. If you get to this point, instead of multiplying through by root 32 over root 32, which you could have done, but that would have made this very complicated, I simply changed root 32 into 4 root 2, and then divided through. Now at this point here, instead of multiplying by root 2 over root 2, you could have actually simplified using the division rule over there. You could have seen that I could have divided root 6 by root 2 and got root 3. So it would have been 3 root 3, which we actually end up getting, despite us going through the whole rationalising the denominator process. If you can spot that, if they've asked you to rationalise the denominator, solve by rationalising the denominator, do that. But know that you can check your answer in a different way. Alright, so that's it for me. If you need some extra help with that, perhaps revisit multiplying and division of surds. Otherwise, yeah, that's it. Thanks very much. Cheers.